go, go, go.
Well, I'm Tim,
And I'm Porter.
and we're gonna do some
Physics.
yeah. So the first thing we're gonna do is we're gonna drop some random objects on this piece of bamboo over here, and we're gonna test the momentum, velocity, the time, everything. So we're gonna drop it at a low height first, and if you're dropping it at a low height, that means it'll have less time to fall, which means it'll have a less velocity at the point of impact, which means less momentum, so more likely of a chance that it's not gonna break. But if it happens at a high height,
The high height, it has more time to accelerate before it hits the bamboo. That's going to give it a higher velocity and more momentum to break the bamboo.
That's it.
I almost forgot. Safety first!
No more concussions for me.
Ready to roll.
Oh yeah.
Here at low height with our 2 kilogram brick. We're going to drop this from about a foot. And this is going to give us a short time to accelerate, which means it's going to reach a small velocity. If it was dropped from a high height, it would have more time to accelerate, which would give it a greater velocity. Since in the momentum formula, P equals mv, the less velocity is going to give it less momentum, which probably won't break the bamboo. So here we go, ready? See? It didn't work. I guess we just need a bigger mass.
Alright, so we have the same brick. It's still same mass. We're gonna drop it at a higher height. So it should have more time to increase its velocity. So it should break the bamboo. I think we need more weight. Alright, so if you can see here, we can close in, you see it cracked in numerous areas, but it didn't break all the way through. So we're probably going to need a bigger mass.
Here we are with the Fair Brothers.
Okay, so we have a bigger mass, and we're going to drop it at the same height as we dropped the brick before, and maybe it'll go completely through. My name is Colin, and welcome to Physics. I hate visual. Okay, so next thing we're going to do is we're going to explain the physics behind the telephone book myth. What you do is, if you have 2 telephone books, 2 books the same size, you put them down page by page or close enough, like we did 10 pages or something. You know, you can't pull it apart. It's too much force. There's not enough force to pull it apart. So one of the factors behind this is friction. If you have friction between 2 pages, or just a page and a page, there's not a lot of it. But if you multiply it by 1,000, it's going to be a lot of friction. So that's one of the factors in this.
When we pull the ends apart, the middle compresses, so that pushes all the air out from between the pages. This creates a vacuum in the middle right here. Okay, so according to Bernoulli's principle, things can only move from high to low pressure. That means that when the paper is stuck in the middle of the system with 0 pressure, it can't be pulled out no matter how much force you apply. Even this amount of force can't pull it apart.
Look at the muscle strains.
Ow. Need someone who can break this.
I know a guy.
Get the camera. You think he'll work?
Oh, he'll do just fine. Colin!
Hey, buddy.
Hey, give it to him, give it to him. Can you rip these apart?
I don't think he can do it.
Not even the giant can do it. It's impossible.
We'll sacrifice this brick to the bamboo gods.
Yeah, looks like we're gonna need a larger mass.